Hi, this is the word solution and marking scheme to your higher straight line homework. So the first question gives us an equation of a line and it asks us to find the equation of a line parallel to this that passes through the point -6, 2. So in order to find the equation of a line, you need to know two things. The first thing you have to know is a point on the line, and in this case we're given -6, 2. And the next thing you need to know is your gradient. Now this question doesn't give us your gradient straight away, but it does give us enough information. So it tells us an equation of a line, and it tells us that the line we're looking for is parallel to this. So we can use that, get it into the form y equals mx plus c, and extract the gradient we need from there. So starting off, I've got x minus 2y minus 8 equals 0, which is my general form. First thing I'm going to do is add 2y's onto both sides of that equation. Now the reason that I'm doing that is so that I can get a positive y, because I want it in the form y equals mx plus c. Again, to make sure that it's in the right order, I'm going to rewrite it as 2y equals x minus 8. So I've just rewritten it the opposite way there. And now I'm going to divide it by 2 because, again, I want y on its own. I don't want 2y. So that's going to give me y equals, be very careful that you're dividing everything by 2, and I get a half x minus 4. So the gradient of this line is a half. The line that we're looking for is parallel to that line, so it's also going to have a gradient of a half. And using the coordinates -6, 2, I know that my a value is -6 and my b value is 2. I can then use that in the formula for finding an equation, which is y minus b equals mx minus a. Y minus 2 equals, my gradient's a half, x minus minus 6. I'm going to tidy up that double negative. So I've got y minus 2 equals a half. Remember, your double negative gives you a positive. And I'm now going to tidy up my fraction. So I'm going to have 2y minus 4. That's by multiplying my left-hand side by 2. And remember, when you multiply your right-hand side by 2, essentially you're just cancelling out that denominator there. So you've then got your 1, which we don't need to write, x plus 6. You can leave it at that point there, that would be absolutely fine, but obviously we're now getting used to leaving it in different formats. So some of you might decide to leave it in the form y equals mx plus c, but as we've discussed several times, I like leaving it in the form 2y minus x equals 10 by moving my x over to the other side and adding 4 to both sides to get all my numbers. And the reason that I do that is so that I can get set up for simultaneous equations, which tends to be the part C of your questions. Now, in terms of where you're getting your marks, for this one you would get your mark for extracting your gradient of a half. That's going to be your first mark, and your second mark would be for finding your equation. So overall, the question's out of 2. Question 2 gives you a triangle ABC. It tells you that AB, which is this line down here, has equation y equals 2/3 x minus 1, and it wants you to find the equation of the line CD, and it gives you the coordinates of C. So remember, to be able to find the equation of a line, you need to know two things. You need to know a point on the line. So in this case, we do know that C is the point -1, 7. We also need to know the gradient of the line. Now, this gradient isn't as straightforward as question 1. This time, the bit of information we need to really look at is that we've got this little right angle sign down here. So that means that the line AB is perpendicular to the line CD. So the line AB meets the line CD at a 90-degree angle. So looking at the equation y equals 2/3 x minus 1, we know that the gradient of AB is going to be 2/3. We can use that to find the gradient of CD, which is perpendicular to that. Now remember, the quick way of dealing with a perpendicular gradient is to flip your fraction upside down and change your sign. So a positive 2/3 would become a negative 3/2. And that is because we know that if we multiply two gradients together, which meet at a 90-degree angle or are perpendicular to each other, gives you -1. So 2/3 times by -3/2 would give me -1. So we now know that that's our gradient. We also know from the point C that A is -1 and we know that b is 7. We can then use that in y minus b equals mx minus a to find the equation of the line CD. So we've got y minus 7 equals the gradient, which is negative 3 over 2, x minus a, so minus 1. I'm going to work through the stages, start off by simplifying that double negative, so when I do that I end up with x plus 1 in my brackets. I'm going to multiply through by 2, so 2y minus 14. Now remember, when you multiply that right hand side by 2, essentially you're just getting rid of that 2. Now I'm going to multiply everything by negative 3 on that side, so I've got my negative 3x minus 3, which is me multiplying out my brackets. Again, that would be perfectly acceptable as your final answer. However, we're getting into the habit of leaving it in the form for simultaneous equations. So I'm going to add 3x onto both sides to get my x's and y's on the left-hand side. And I'm going to add 14 onto both sides to get 11 on the right-hand side. And that's me done at that point. So again, this is out of 2 marks. So you would get your first mark for being able to find your perpendicular gradient. And you would get your second mark for subbing into y minus b and multiplying out. So question 2 is out of a total of 2. Question 3 is asking us to calculate the size of the obtuse angle between the line y equals a half x minus 3 and the x-axis. So any question that refers to a straight line and talks about your angles, you're going to be using the formula m equals tan theta. Now for m equals tan theta, you can be given the gradient and asked to calculate the angle, or you can be given the angle and asked to calculate the gradient. In this one, we're asked to calculate the size of the angle, and we can extract the fact that our gradient is equal to a half because the equation we're given is in the form y equals mx plus c. So we can substitute that half into our formula. So we've got a half tan theta. We want to try and find theta, which is the angle it makes with the positive direction. To do that, we're going to do tan inverse of a half. Stick that in your calculator and you find that it's 26.6 degrees. Now, if you think about what this means on a diagram, we've got a line something like this. So it's passing through negative 3 and it's got a gradient of a half. Now with our positive direction of our x-axis, it's this angle in here. That's always going to be an acute angle. So what we need to do is find out the size of this angle. Now given that that's a straight line, we can use the fact that we know that's 180, take away the 26.6 degrees that we got, and we get 153.4 degrees as our final answer. That's our obtuse angle. In terms of where you're getting your marks for this one, you'll get your first mark for your 26.6, your second mark for your 153.4, and that's your 2 marks here. Now you'll notice that you also got what we called hashtag marks. So remember, these questions are taken from old unit assessments. And your hashtag marks for this would be understanding that you're using your m equals tan theta and you're using it to calculate theta degrees. Final question in the C-level questions, question 4, says that in the building industry there are categories of roof based on the steepness of their slope. We're given a table which defines them and we're asked which category the roof represents in the diagram below. So we're given a picture. In that picture, we've got the negative angle. Okay, so that 159 is your negative angle. Positive direction would start here and travel over. So again, taking advantage of the fact that you know there's 180 degrees in a straight line, we can do 180 minus 159 and we get 21 degrees. So the angle that we're going to be using is 21 degrees. We know that we're using the formula m equals tan theta because it's talking about angles and straight lines again. This time we're trying to calculate our gradient by substituting in our angle. So m equals tan 21. Tan 21 in your calculator gives you m equals 0.3838 and some more numbers. Given the fact that every value in my table is rounded to 2 decimal points, I'm going to round this to 2 decimal points as well. So 0.38 if we look at our categories, well, it's not less than 0.08. It doesn't lie between 0.08 and 0.33. And it's not greater than 1.75. So we can write, therefore, roof is high sloped. And that's the end of my question there. So in terms of your marks for this question, you would get 1 mark for calculating your 0.38, and that's the only mark for this question. Then you also get this hashtag mark, and that is for writing out your statement, so to explain what it means. So for this, therefore roof is high sloped, that would get you your hashtag mark. The next question you were asked was an exam level question, so this is straight from an SQA past paper. Now remember, when you're given diagrams in an exam, you can be confident that they are going to be pretty accurate. So the point A is 7, 9. Looking at where that is in the diagram, that makes perfect sense. They're both positive coordinates. B is the point -3, -1. So again, that makes sense if you look at it. They're both negative coordinates. And then C is the point 5, -5. And that makes sense because your x coordinate's positive, not as high as the value of A, because C clearly lies to the left of A. And your y coordinate's negative, clearly below your y coordinate on your B as well. So, question's got 3 parts to it. Part A wants you to show the equation of the perpendicular bisector as y equals 2x minus 5. They're the type of questions that we quite like because it's asking us to show something and it's giving us our final answer. So if you don't get to y equals 2x minus 5, you know that you've made a mistake, and that's something that hopefully you can go back and fix. Part B is asking us for the equation of the medium, and part C wants us to find the coordinates of the points of intersection. So for parts A and B, I know that I'm going to have to set myself up for simultaneous equations to get through part C. So let's have a look at question A. So again, it wants us to show the equation of the perpendicular bisector of BC as y equals 2x minus 5. So that dotted line is a perpendicular bisector of BC. So that's got 2 parts to it. The first part is perpendicular, so it means it meets it at a 90-degree angle. The second part is that it's a bisector, so it cuts BC in half. So they 2 sections are identical in size. So we're going to work our way through that, starting off with the fact that we know that it's perpendicular. So if it's perpendicular to BC, the first thing we need to do is calculate the gradient of BC. Now I always label my points just so that I know that I'm being accurate with it. So there's xy and xy. I'm going to call this set 2 and this set 1. So thinking back to National 5, your equation for finding the gradient, y2 minus y1 over x2 minus x1. And I can substitute in. So my y2 is -5. My y1 is -1, so I'm taking away -1 over x2 is 5, and I'm taking away -3, which is my x1. So on the top, I've got a -5, take away -1. If I take away a negative, I'm going to be adding them, so -5 plus 1 gives me -4 over 5, take away -3, again that would become a positive, and it would be a positive 8. Remember, wherever you can, simplify your fraction, so that is going to be -1/2. So that's the gradient of BC. The line we're interested in is the perpendicular bisector of that. So if it's perpendicular, it means it meets at a 90-degree angle, and the perpendicular gradient of -1/2. So remember, if you're trying to do this quickly, the best way to think about it is flipping your fraction and changing your sign. So if we have -1/2, we're going to change that to a positive 2/1, but we would just write that as 2. So it's a positive 2/1, but we don't write over 1. And remember, the reason that that works is because if we times the gradient of BC by the perpendicular gradient, it would give us -1 because they're perpendicular. Next thing we need is a point on the line. So in this case, we know that it's going to be the midpoint of BC. So remember, capital M for midpoint. and we're going to add our two x's together and divide it by 2, add our two y's together and divide it by 2. So my two x's, x1 is negative 3 plus x2 is 5. y1 is negative 1 plus negative 5 for y2. So that's going to give me, so negative 3 plus 5 gives me 2 over 2. Negative 1 plus negative 5 gives me negative 6 over 2. So my midpoint must be 1, negative 3. And if I look at it on the diagram, I was trying to find this point here, and that does make sense that it's 1, negative 3. So it's a positive x and a negative y. Also, if you compare it to the x and y coordinates of BC, it makes sense. So what we were saying is that 1 lies halfway between negative 3 and 5, and it does, it's 4 either way. Negative 3 lies halfway between negative 1 and negative 5, and it does because it's 2 either way. So I'm quite happy that that's the points that we're going to be using. So we know that our gradient is 2, our a value is going to be 1, and our b value is negative 3. We can now sub that into y minus b equals m, x minus a. And remember, we're trying to get to y equals 2x minus 5. So we've got y minus negative 3 equals 2x minus 1. I'm going to simplify that double negative and break my brackets. So I've got y plus 3 equals 2x minus 2. The question asks us to write it in the form y equals mx plus c. We have to do that to show that it is what they're asking us to show. So I'm taking away 3 from both sides, and I end up with y equals 2x minus 5. And because that's what they wanted, I'm going to write as required at the side. Now, because I know part C is coming up and part C is going to involve simultaneous equations, I'm going to take this y equals 2x minus 5, and I'm going to get it set up for C by writing it with my letters on the left-hand side, so subtracting 2x from both sides, and I'm going to keep that negative 5 on the right-hand side. So this is the form that I'm going to be using when I get to part C for simultaneous equations. Moving on to part B, it wants us to find the equation of the median from C. So median is all the m's, it's your gradient and it's your midpoint. If it's from C, it means it's starting at the point C and it's travelling over to the midpoint of AB, which is here, and I'm going to call that capital M for midpoint. Midpoint means that these two sections are going to be the same, so it's in the middle of AB. When we're doing the equation of a line, we need a point on the line. In this case, we've got C and we're going to find M. To be able to calculate our gradient, we need 2 points. So that would be the C and M. So the first thing that we need to do is calculate the midpoint of AB so that we've got a second coordinate to find our gradient. So for A and B, I've got my X and Y and my X and Y. And for consistency, I'm going to write that these are my 2's and these are my 1's. So for your midpoint, you know that you're just combining your X's and combining their Y's. But so that I'm always labelling them as 0.2's and 0.1, I'm going to stick with that and make sure I'm being accurate. So I've got X1 plus X2 divided by 2. Y1 plus Y2 divided by 2. If I start to substitute my values in, so I've got negative 3 plus 7 over 2, negative 1 plus 9 over 2, and I can simplify that, becomes 4 over 2, 8 over 2, which goes down to 2, 4. If I look at this point here, my M here, that makes sense that it would be 2, 4. If I consider it in terms of my A coordinates and my B coordinates, 2 does lie halfway between negative 3 and 7, it's 5 either side. And 4 does lie halfway between negative 1 and 9, it's 5 either side. So I'm pretty confident that that is the correct midpoint. So I can now use that midpoint and the point C to find the gradient of the line, the gradient of the median, the gradient of MC. So this is an X coordinate, this is a Y. This is an X, this is a Y. I'm going to call this set 1 and this set 2. So again, back to National 5, Y2 minus Y1 over X2 minus X1. I've got 4 minus negative 5 over 2 minus 5. This simplifies to 9 over negative 3, which I can then reduce right down to negative 3. Okay, so there's my gradient. Down here, my 5 and my negative 5 are going to be my A and B. Now, because I've already labelled them X and Y, just to be super clear, I'm going to write out that A is 5 and B is negative 5 over at the side here. We can now use our Y minus B equals X minus A formula. So we've got Y minus negative 5 equals negative 3X minus 5. I'm going to simplify and multiply out my brackets, tidy up all these negatives. So double negative here gives me plus 5. Multiply out by negative 3 gives me minus 3x plus 15. Be very careful with that double negative. And then I'm going to rearrange it into the form that I like to use for simultaneous equations. So I'm going to add my 3x to both sides to get my y's and x's on the left-hand side. And I'm going to take away 5 from both sides to get 10 so that I've got my letters over there. So this is me setting it up for simultaneous equations, and I can now use that in part C. So for part C, it wants us to find the point of intersection of the bisector of BC and the median from C. So essentially it's asking us to find these coordinates here. Okay, so straight away I'm going to say that we're looking for a positive x coordinate and a positive y coordinate. So remember, our coordinates that we get should make sense with that diagram. So in part A, we found that our first equation was y minus 2x equals negative 5, and our second equation was y plus 3x equals 10. So remember, I set them up specifically for using them in simultaneous equations. If you do your simultaneous equations differently, then obviously you would have yours set up differently as well. So I have got two y's. They're both the same coefficient, so these are what I'm going to be subtracting. So I'm going to do y's take away, x's take away, and then my numbers on the right hand side take away. So what I've got when I do 1 take away 2, y take away y eliminates my y's, negative 2x take away 3x gives me negative 5x, negative 5 take away 10 gives me negative 15. So that means that my x coordinate must be 3. I can now sub that x is equal to 3 into one of my two equations. So I'm going to go with equation 1. So I've got y minus 2x, but I'm going to replace my x with 3 equals negative 5. So y minus 6 equals negative 5. So y must be equal to 1. Looking at the coordinates that I've just got, it's got an x coordinate of 3, y coordinate of 1, and comparing it to this point here, that does look pretty accurate. They've worked out as nice numbers as well, so I'm going to say that my point of intersection is 3, 1. Okay, remember, always state the coordinates when it asks for coordinates. Looking back to part A was out of 4. So in terms of your marks for this question, you'll get 1 mark for finding the gradient of BC. That's your first mark. Your second mark will be for finding your perpendicular gradient. That's your second mark. Third mark is for finding your midpoint of BC. And then your final mark is for showing what they've asked you to show and getting to y equals 2x minus 5. For part B, this was out of 3. So mark 1 would be for finding your midpoint of AB. Your second mark would be for finding your gradient of MC. And then your third mark would be for finding your equation, which would be from this line here. Okay, remember this part here is just us setting up for simultaneous equations. Your mark would come from the line before where you've expanded your bracket. And then for part C, this was also out of 3. So you'll have 1 mark for finding that x is equal to 3, 1 mark for finding that y was equal to 1, and then your third and final mark will be for your coordinates. So the final question you were asked was the extension question. Now this is from an old higher pass paper. The older papers do tend to be a little bit trickier. And remember, the further through the paper a question is, the more difficult it will be as well. So they're the good things to look out for when you're trying to extend yourself. Now this question is quite lengthy. There's 3 different parts to it. There's different diagrams as well. So before I even read this, I'm just going to go straight for splitting it up into chunks and work my way through each part individually. So first part, it says that you've got a diagram which shows rectangle PQRS and it gives you the coordinates of P and Q. It wants us to find the equation of QR. So it wants us to find this equation here. It's telling us that this is a rectangle. So the fact that it's telling us that this is a rectangle means that it wants us to be able to gain some information from that. And that information will be that this is a 90-degree angle. So in other words, what they're leading you to is that this line here, QP, must be perpendicular to QR. Now remember, when you're finding the equation of a line, you need to know 2 things. You need to know a coordinate. In this case, we've got the coordinates of Q, which lies on the line QR. But we also need to know the gradient, and we now know that we're going to be able to find that. So the first thing that we're going to do is find the gradient of QP. So I'm going to label my coordinates. So there's x, y, x, y. I'm going to call this set 2 and this set 1. So remember your formula, y2 minus y1 over x2 minus x1. And I can then start to substitute in. So I've got 2 take away 6 over 7 take away 5. 2 take away 6 gives me -4. 7 take away 5 gives me 2. So I've got -2 as the gradient of the line QP. Looking at the line QP, that makes sense. It's clearly a negative gradient and it is pretty steep. So QR is perpendicular to that line. So if we know that the gradient of QP is -2, remember, to find a perpendicular gradient, you change your sign and flip your fraction upside down. Now remember that 2 is 2 over 1. We just don't always write that. So -2 over 1, perpendicular to that, is going to be positive 1 over 2. Okay, and that is because when we multiply these 2 gradients together, we are going to get -1. So we now know that we've got a gradient of a half. If we refer back to the question, it's asking us to find the equation of QR, and we know the coordinates of Q. So we've got an A value of 5 and a B value of 6. We can then substitute this into our y minus b equals mx minus a formula to find the equation of QR. So we're going to have y minus 6 equals a half x minus 5. I'm going to deal with that fraction by timesing everything through by 2. So I've got 2y minus 12. Remember, when you times your right hand side through by 2, essentially you're just getting rid of that denominator. And I can now multiply my bracket by 1. Gives me x minus 5. That would be perfectly acceptable as a final answer. But remember, we want to leave it in a different form for simultaneous equations, and some of you might even be leaving it in the form y equals mx plus c. So I would always leave it as 2y minus x equals 7, because that would set me up for simultaneous equations if I needed it. So for part B, it says the line from P with the equation x plus 3y equals 13 intersects QR at T. All that information is then given to you in a diagram, and it wants us to find the coordinates of T. Okay, so the line from P, this line here, has equation x plus 3y equals 13. We're trying to calculate T, and in part A, we calculated the equation of the line QR. So we're going to be using simultaneous equations to find this point of intersection here. Okay, so if I go back to part A, I set myself up for simultaneous equations down here when I got my 2y minus x equals 7. So my first equation is 2y minus x equals 7. That's my equation 1. And my second equation is given to me in the question here. So I'm going to write my 3y on this side plus x equals 13, and this is equation 2. Okay, so I'm going to be getting rid of my x's because my x's are the same. It's both single x's. Because one's positive and one's negative, they've got different signs, so we're going to add these two equations together. So I'm adding equation 1 and equation 2. So remember, you add your y's, you add your x's, and you add your numbers on the right hand side. So 2y plus 3y gives me 5y. Negative x plus x eliminates my x. 7 plus 13 gives me 20. So y must be equal to 4. I can now sub y equals 4 into either one of my equations. I'm going to go with equation 2. So rather than having 3y, I'm going to sub in that y is 4. So I've got 3 times 4 plus x is equal to 13. 12 plus x is equal to 13. So x must be equal to 1. So that means that t must have the coordinates 1, 4. If I look at my diagram, t is quite clearly in the positive x direction and the positive y direction. So I'm quite happy that that's going to be my final answer. So that was for question B. So looking at part C now, it says given that t is the midpoint of QR, find the coordinates of r and s. So we're going to have a look at what's happening on this top line, RTQ. So the coordinates Q are 5, 6. The coordinates of T, which is now the midpoint we know of this line, are 1, 4. And we're going to start off by calculating R. Now for this, you can use your midpoint formula, but I quite like using this method. So this is your stepping out method. This will be useful to you in a couple of different topics that we're going to be doing this year. So it's worthwhile getting the practice in of it just now. So everything must be moving equally because T is our midpoint. So if we look at what's happening between Q and T, our x coordinate is dropping from 5 to 1. So our x coordinates are dropping by 4. So that means the difference between this coordinate t here and r, the x is also going to have dropped by 4. So 1 take away 4, r must have an x coordinate of -3. Similarly, for our y coordinates, they're dropping from 6 to 2. So there's a shift in 2 on our y coordinates. So we're going to do the same. So t has a y coordinate of 4. We're going to drop it down by 2 and we'll get a y coordinate of 2 for the point R. Looking at our diagram, it does make sense that R has the coordinates -3, 2 because it has went back on the x-axis and up on the y-axis. We're now going to use the fact that we've got a rectangle to help us calculate our S as well. So now looking at the change in QP. So Q is the point 5, 6 and P is the point 7, 2. We now know that parallel to this, we've got R, which is the coordinates -3, 2, and we're trying to calculate S down here. Okay, so from Q to P, the difference in our x coordinates, we've went up by 2. In other words, we've shifted to the right by 2. So the same thing's going to happen on the x coordinates between R and S. So that -3 is going to become a -1 because we're adding on 2. We're getting closer to our y-axis in this case. If we look at what's happening between our y coordinates, so this 6 here is dropping down to 2, so there's a shift by -4. So that means that this y coordinate of 2 for our R is also going to drop down by 4 on our SY coordinate, which would get us to -2. So S is the coordinates -1, -2. And again, if I look back up to my diagram, it does make sense that that point there has got a negative X coordinate and a negative Y coordinate. So I'm quite happy that they are what I was looking for. If we look at where you would be getting your marks for this extension question, so part A was out of 3. Your first mark is going to be for finding the gradient of QP. So here's mark 1. Mark 2 would be for recognising that you're going to have to find a perpendicular gradient. So mark 2 is for my half. And then I would get my final mark for subbing into y minus b and coming up with the equation. So where I've put this tick, that was where you would get your mark. Remember that this was just me setting up for simultaneous equations. You don't have to rearrange once you've expanded your brackets. That second to last line is acceptable for that mark. For part B, you're going to get your first mark. So this one's out of 3. Your first mark would be for finding an x or a y coordinate. Your second mark would be for finding the alternative. And then your third mark would be for your coordinates. So in this case, t was 1, 4. For part C, which was also out of 3, you're going to get 1 mark for understanding the strategy that you're going to be using. So for doing something like your stepping out method or using your midpoint formula, which would lead you to one of your values. Your second mark would be for either -3, 2 or -1, -2. And then your third mark would be for the alternative.